Thanks for watching this screencast. In this screencast, our objective is learners will be able to evaluate expressions involving absolute value. And you probably have some experience working with this before, or at least have some concept of what absolute value means. We're going to define it this way. The definition of absolute value is that it is the distance between a number and zero on the real number line. So we use this symbol, this notation here, the absolute value of x. We draw vertical bars around the number we want to find its absolute value on either side. That's the notation that we use. So the number line is really convenient for looking at something like this. If I ask you to figure out what the absolute value of 4 was, you'd simply say, well, here's where 4 is on the number line. How far away is it from 0? And what's that distance? Well, that distance, remember that distance is always a positive value. That distance is 4. If by contrast I ask you what the absolute value of negative 2 was, well, you would say, well, here's where negative 2 lies. The distance between negative 2 and 0 on the number line is 2. So the absolute value of negative 2 is 2. A common misconception students have is that the absolute value of a number is the opposite of the number. That's not what it is. The absolute value of a number is simply how far away from 0 is that number on the number line. The skill specifically that this screencast is designed to help you accomplish is to simplify expressions that have absolute value in them, like the one shown here. When evaluating those expressions, absolute value bars, you should think of them as a grouping symbol. If I tell you to simplify an expression, you should simplify everything inside that absolute value setup and then find its absolute value. Think of it as another set of grouping symbols. So we'll do this example together. It says evaluate 8.4 minus the absolute value of 2n plus 5 if n equals negative 7.5. So all I need to do to evaluate this is to replace n with negative 7.5. Keep everything else the same. It's worth pointing out from our first objective that this is an expression and not an equation. We just want a value. So I'm going to treat everything inside the absolute value symbols like grouping symbols. I'm going to do all of this stuff first. So my next step is going to be to simplify using order of operations in here. I've got 8.4 minus, the first thing I should do inside here is multiplication. Remember that multiplication should happen in order of operations before addition does. So 2 times negative 7.5 is negative 15. And then with these two things left, now I can simply perform that last operation addition. So I've got 8.4 minus the absolute value of, and negative 15 plus 5 is negative 10. And we've reached the part where I've simplified everything inside the absolute value notation. So now what I should do is I should figure out what the absolute value of that number is. What's the distance between negative 10 and 0 on the number line? Yeah, it's 10. So I've got 8.4 minus, notice the minus is the same minus that was here. And then the absolute value of negative 10 is 10. So now, this is a pre-algebra problem. Simplify this, actually a middle school math problem. Negative 10 plus 8.4 is negative 1.6. This expression, if n is negative 7.5, should have a value of negative 1.6. Alright, let's do another one together. This one says evaluate the expression absolute value of 4x plus 3 minus 7 halves if x equals negative 2. I know exactly what to do. I need to replace x with negative 2. Remember that we know that 4x means 4 times x. So 4 times negative 2 plus 3. And then the absolute value of that all, then subtract 7 halves. Well, order of operations inside this set of grouping symbols, 4 times negative 2 would be negative 8 plus 3 now, minus 7 halves. I can combine these two terms here. Negative 8 plus 3 would make negative 5. And I've reached that key point again where I've simplified what's inside the absolute value bars as much as possible. Now I need to figure out what the absolute value of negative 5 is. It's 5. And 5 minus 7 halves. You might need to either think about 5 being 10 halves, if you want to give an answer that is a fraction. 10 halves is the same as 5. The reason that's important, I hope you'll recall, is that if you're going to subtract two fractions, they have to have the same denominator. And if they have the same denominator, then you can simply subtract the numerators in this case to get 3 halves. Here's the first time we've encountered something like this in our course, but it's worth pointing out, there is nothing wrong with giving a decimal value for your answer. It has the same meaning as 3 halves. So in our course, both of these answers will be acceptable. There's no reason why I would take one answer over the other. And if there's a reason for what we're using our math skills for that I would prefer to see an answer written one way over the other, I'll of course tell you about that. Okay, it's your turn now. What I'd like you to do is to pause the video and try to answer this question. Can you evaluate 4/3 minus the absolute value of 2y plus 1 if y is negative 2/3? Hit pause, try it, and then when you're ready to check your work, hit play and we'll check it out. Alright, how'd you do? Well, if I replace y with negative 2/3, here's what I get. I get 4/3 minus the absolute value of 2 times, not y, but negative 2/3 plus 1. And in simplifying what's inside the absolute value bars here, I may need to think about how to do this. How do you multiply a whole number by a fraction? If you need to go off to the side and do that, there is no shame at all in doing that. It might be helpful to think about 2 as 2 over 1. And the thing to remember is that to multiply two fractions, you simply multiply the numerators and multiply the denominators. So 2 times negative 2 would make a negative 4, and 1 times 3 would be 3. This is going to make a negative 4/3. So I have 4/3 minus the absolute value of negative 4/3 plus 1. And to simplify what's inside the absolute value bars here, negative 4/3 plus 1 might be more conveniently written if I want to write the 1 as something involving thirds as 3/3. So if negative 4/3 plus 3/3 is what I need, that would be a negative 1/3. So I've got 4/3 minus the absolute value of negative 1/3. And now I need to decide the absolute value of this term. The absolute value of negative 1/3 is positive 1/3. So I've got 4/3 minus 1/3, that's 3/3. And that's not an incorrect number, but I hope that you're going to write that as 1. 3 divided by 3 is 3/3, that's 1. Thanks for watching.